Hey, welcome back, Casibang's crew. This video today we are going to be talking about the ear and audition, okay, how we hear. All right, so first, let's talk about the anatomy of the ear. Just like we did with the eye, we are going to be diagramming the ear. So we're going to go over all the parts of the ear and what it does, and then tomorrow we will diagram where exactly it is in our ear. So just like with the eye, we have kind of a weird mnemonic device to help you remember all of the parts of the ear and to help you with the order in which the ear hears the sound, okay? The order through the ear at which the sound goes in. And that mnemonic device is patusha. And I always say it like that because I think it's a funny way to say it. So it's patusha. All right, so the first part is the pinna, the P, and patusha is pinna. And this is the outermost part of your ear. So this is like this part of your ear, okay, the part that we can all see. All right, the A is for the auditory canal. This is where the sound waves enter and then travel into your ear. If you put your finger in your ear or you put a Q-tip in your ear, you're putting it into your auditory canal. The T on there is for the tympanic membrane, or otherwise known as your eardrum, more commonly known as your eardrum. And this membrane seals the inner ear from any dirt or debris, Q-tips, anything that you might stick into your ear so that it doesn't go further into your ear. When sound reaches this point, the eardrum begins to vibrate at the same rate as the incoming sound waves. The C is for the first O. I'm sorry, I'm ahead of myself. The first O in there is for the ossicles. Okay, the ossicles are found behind the eardrum, and it is 3 tiny bones. They are actually the smallest bones in the human body. Okay, 3 tiny bones that pick up and transmit sound waves. It includes the hammer, the anvil, and the stirrup. Together, these 3 bones are called the ossicles. That second O is for the oval window. The last bone in the ossicles, the stirrup, connects to the oval window. And this is a membrane that begins to vibrate at the same frequency as that initial sound wave. And this action allows fluid in the cochlea to vibrate. So this is how we're sending that message. All right, the C is for the cochlea. This is your main organ of hearing. The cochlea is where transduction happens inside the ear. Really important to know this. Put a star next to that. Okay, it is snail-shaped. It is all curled up, and it looks like a snail, like a snail's house almost. And it is filled with fluid. So the fluid in your ear vibrates, and it stimulates hair cells that are inside the cochlea. So that H is for the hair cells. Okay? It's here in the hair cells in particular where those vibrations are converted or transduced into neural impulses that can be used by your brain. Fibers at the end of the hair cells collect the impulses. And then these fibers join together and form the auditory nerve. And that is the last A in patusha. And that is the auditory nerve. Okay, so here's a diagram. And like I said, we are going to do a diagram in class. We're going to use this exact one, actually. But here's the cochlea. You see how it is like coiled up in the shape of a snail. So down here in this picture here, we actually uncoiled the cochlea so you can see kind of the inner, the hair cells that are on the inside of the cochlea there. But we will diagram this in class tomorrow. All right, so our sense of hearing, just like we talked about with our vision and wavelengths and the intensity and hue, audition, or our sense of hearing, also has to do with wavelengths, but they're a little bit different. So the first thing that we talk about with hearing is frequency. So this is the number of complete wavelengths that passes a point in a given amount of time. So say, for example, we're looking at 10 seconds. How many wavelengths of sound pass this particular point in 10 seconds? And that's going to give us our frequency. And then the second one is pitch. And this is how a tone or a sound sounds. Its highness or lowness, okay? And your pitch depends on the frequency. So how do we measure sound? So the length of the wave is pitch, and pitch is measured in hertz, okay? The number of waves that reach the ear each second. Okay, and then amplitude, just like in vision, okay, the amplitude is the height of the wave. And this time, the amplitude or the height is going to measure loudness. And this is decibels, okay? It's measured in decibels. Okay, so prolonged exposure to 85 decibels or above will cause irreversible hearing loss. So every time you have your earbuds in, or if you have headphones on and you're listening to music really loud, or you're listening to your video games really loud, this could be damaging your hearing, and you won't know about it tomorrow or next week or next month. You're probably going to find out about it when you're in your 30s and 40s and you can't hear anymore. Okay, so we used this image when we were talking about wavelengths in our vision, in our eyesight. So here again, we're using the same waves, the same examples to talk about audition or talk about our hearing. So again, short wavelengths, okay, measured from the peak of one wave to the peak of the next wave, is high frequency sounds. Okay, so again, bluish colors in our vision, but high pitched sounds in our audition. Long wavelengths, again, measured from peak to peak. Low frequency, okay, so low pitched sounds, but give us reddish colors in our visual system. And then amplitude, the height of the wave. So a large amplitude or a high height gives us really bright colors. It also gives us very loud sounds. And then small amplitudes give us dull colors and very soft sounds. All right, so when we're talking about decibels and potentially damaging your hearing for the rest of your life, this gives you a good idea on a decibel chart. So 0 decibels, okay, you're not hearing anything. About 20 is a whisper. About 40 is a typical room with people and movement happening in it. 60 is a normal conversation, and 80 is a busy street corner outside, okay, trucks and cars passing by, maybe honking horns, those kind of things. A subway train from 20 feet away is in the danger zone of decibels. A jet plane from 500 feet away. Loud thunder. Okay? Think of some of our summer thunderstorms. And then a rock band, okay, 140 decibels. So this is prolonged exposure for anything up here in this pink to red range could potentially cause permanent hearing loss. All right, so how do we perceive pitch? So there's a couple of theories here, just like there were a few theories on our color perception. There's a couple theories for how we perceive pitch. The first one is place theory. So this theory says that the pitch that we hear has to do with the place on our cochlea, that little snail-shaped thing, where on our cochlea the membrane is actually stimulated. Okay, so place is literally the place in your cochlea that is being stimulated by the sound vibration or the sound wave. Frequency theory says that the rate of the nerve impulses that are traveling up our auditory nerve, okay, the auditory nerve goes right into our temporal lobe. So the rate of those nerve impulses matches the frequency of the tone, and that is what enables us to sense pitch. Okay, we're not sure which one of these, or maybe the combination of the two of them together are true. They explain different things about how we perceive pitch. All right, and then hearing loss. Okay, there are a couple causes of deafness. Birth defects. Okay, something happened when you were in mom's uterus, and your ears or your auditory canal or your cochlea or even that part of your brain, your auditory cortex, did not develop correctly. You could lose your hearing due to disease, advanced age, injury, okay, like you've got hit or you poked something into your ear, okay, and you perforated your eardrum or something like that. There are two types of deafness. The first one is conduction hearing loss. So this is when you've done damage to the middle ear, the ossicles, those three little bones that are in the middle of your ear. So it could be that you punctured your eardrum, so you stuck something in your ear and it went too far and you punctured that membrane. It could be that you've done damage to those bones of the ossicles so that they're not able to vibrate properly. So the sound stops there. If it can't vibrate through the ossicles, then it can't reach our cochlea. Sufferers might benefit from hearing aids to amplify the sound waves. And then the second type is sensory neural hearing loss. So this is damage to the hair cells that are on the inside of the cochlea, or damage to the auditory nerve. So we're talking about the innermost part of our ear. And sensory neural hearing loss is what can happen if you've been exposed to extremely loud sounds. It could be disease, it could be aging. And for sensory neural hearing loss, cochlear implants are sometimes successful to restore hearing for this type of hearing loss. Here is an image of a cochlear implant. So down here, this is what it looks like on the outside. Okay, looks like a wire that's kind of put over the back of your ear. And then there's a wire that leads to a lead that is permanently attached to your skull. And here, this is looking at it. So it's the transmitter here. Okay, there's a microphone that picks up the incoming sounds. And then on the inside of your skull, there's a receiver or a stimulator that again has another little wire or lead that goes right past, these are those small tiny bones of the ossicles, but it goes right past them and right into your cochlea. That's why it's called a cochlear implant. Okay, so this bypasses all of this part of the ear, that ear canal, the eardrum, the tympanic membrane, and right past those bones of the middle ear, and sends the message right here to the cochlea, so then it can go right out the auditory nerve. All right, so pretty amazing things that are happening with cochlear implants here. All right, so that is all about the ear and our sense of audition. Again, we will diagram the ear tomorrow, so be prepared to do that. Please come in with any questions that you might have about hearing or audition. I'll see you guys tomorrow. Bye.